device attack. So we're looking at this picture here. We've got the idea of someone gaining access to or breaking in to steal the credentials on a device and then using them to spoof a device. Or perhaps somebody can get onto your end device via a port. They connect in, say, for example, via RS-232 or some other communications mechanism. There's also things like gaining access to your valuable IP and software. So perhaps you have really sensitive software on your product, and you don't want somebody getting on there to take that software and reverse engineer it and use it to their own advantage. And of course, in the same breadth, when somebody is onto your device, and typically they can take control by introducing some kind of like a Mirai botnet, which would take control of the device, and then they can use it against you and use it to target other services and take them out. So that's one area. If you look at things like the network attack, now that's quite a complicated area. But the use of public networks and complicated communication architecture doesn't come without its problems. You have things like multiple entry and exit points. And I like to use one example here, which is MQTT, which is a publish and subscribe communications protocol. And this typically requires a broker which could reside in the cloud somewhere. Now, if you're using sort of transport level encryption, then your data would be encrypted from your device or your client to the broker. But then you've got to think about, well, okay, so how do I protect my data going from the broker to your server or your back-end system? So that's when you really need to think about the whole system from a top-level view. You then got things like the server attack, and so looking at that, people can gain access to the data on the server and perhaps control the access to your devices connected to your service. And even though things like disgruntled employees, perhaps you've got a rogue employee who wants to do some damage to your systems and take the data and even maybe sell it. And actually, only recently we've seen a number of articles come out from various organisations. One was Business Mirror. And they can have a raft of potential impacts, including things like the product becoming useless, people gaining access and reverse engineering your code. The firmware could change, I can no longer control my product. And ultimately, it could be that it's expensive to fix. So, John, just taking these things into consideration, why do you think this is important?
Thanks, Rob. Yeah, so why is this important? So why is this important? We've seen how, and this is not the subject of the webinar, but IoT opportunities are appearing everywhere in terms of operational effectiveness, through to new product or service offerings, and indeed servitization, turning product into a service. But there's also comes along with that increased value, there's a fundamental change. The risk is now outside in an environment that bluntly you can't control directly. What happens to your product as it comes out to the market is not in your control, or how it's looked at or used. So what happens if your product becomes a digital double agent, if you like, where you no longer control it and you can no longer be sure that it's on your team? Well, the first areas that we sort of simplified this in sort of 5 key areas of risk that you need to consider. The first is safety. For example, connected vehicles. A successful hack could impact functions and safety of the vehicle, through to, in other environments, the medical device environment, where literally your product is becoming part of a person and attacking the medical device and causing those sort of potential problems there. And regulators have started to act against this basically around the safety area and have come up into the compliance risk. And in the area of compliance risk, we've got 2 main areas that we've identified that you have to consider as broad areas of feature. The first is data security, from securing an individual's data and the access to their data. In this area, we've got things like the General Data Protection Regulation in Europe, which is coming into force next year, or indeed in the States, where we've got in the medical area, the American Health Insurance Portability and Accountability Act, or HIPAA, the group of regulations that you must comply with in terms of how you're managing, looking after people's data, and in HIPAA's case, medical information. And obviously with GDPR, there are significant risks of, if you are not compliant with GDPR, you can be fined up to 4% of annual global turnover, or 20 million euro, whichever is greater. I'll just let that sink in for a minute. So this is a maximum fine that can be imposed for the most serious infringements, but it doesn't have to be, e.g. for not having sufficient customer consent to process data, or in violating some of the core privacy design concepts of the GDPR. There's a tiered approach, though, to fines as well. So you can be fined up to 2% for not having records in order and not notifying a supervising authority about a data subject, about a breach, or not conducting impact assessments. So it's important to note these rules and apply to both controllers and processors. Even the clients will not be exempt from GDPR enforcement. Then we have a different other area of compliance, which is around industry-specific compliance. So, for example, in Europe on medical devices, the new medical device regulation, which is covering security in medical devices, and some of the US FDA equivalents. Fines in these areas are sometimes less eye-watering. They're only $50,000 per breach of individual items, there for up to 2 million. But bluntly, they open you up to further litigation if an individual is affected by a failure that shows that you were not following the industry standards. So that's the area of compliance risk. The other area to consider is intellectual property risk. Now, industrial espionage, frankly, is not new. Some of the earliest documented cases have ranged from stealing the process for making porcelain from China and importing it into Europe, through to the East India Company bringing the secrets of tea growing to India from China. These sort of famous cases are also augmented in the 80s, etc. People like Hitachi who somehow managed to get their hands on the design and technical blueprints of IBM workbooks back in the day. And this sparked a war between the two technology giants, where IBM, together with the FBI and the counterintelligence agencies, were able to exploit the company's planned industrial espionage. Many high-ranked officials in Hitachi were found guilty, and eventually the two companies agreed on an out-of-court settlement. So this is real and damaging, and if you're not securing your intellectual property, you're giving an option for your competitors to have an easy access to the investment that you've worked hard on to secure. The one that we do come across, and we probably hear more of, is the operational implications. So in an industrial setting, this can result in downtime because your device or thing isn't under your control or not responding in a way that it's meant to. From a product that you're putting out into a field, there's a risk that if you've had a lapse in security and someone's got control of your device, then it becomes as useful as effectively as a brick, or it becomes a bricked product as it's known, which requires a physical recall rather than just a firmware update. And clearly there's a cost associated with that. But also there's the customer service disruption around that. Not only have you physically got to go out to site, but you have to deal with all the phone calls and, bluntly, all of the reputational risk that comes along with that and your reputation. And that's where it comes onto the financial risk, and that's where I put the reputational. All of this ends up in the financial bucket for you. We've covered off the fines and the scale of the fines there, but also it is in this brand reputation. And most of the value of a corporation is intangible. 83% of the FTSE 100 valuation is based on intangible assets, and at a stroke of a pen, those intangibles can disappear overnight, and we've seen that in some cases, particularly with Chrysler on its connected vehicles incident. So we've talked about some of why it's important, why you should really think about it, but let's give you a couple of real-life examples of where, bluntly, people have got it wrong. So Rob, take me through some of those things.
Okay, yeah, thanks, John. So in the next sort of couple of slides, I really just want to talk you through some of the examples like John was discussing there. And this first example actually is quite recent, whereby a group in Italy, basically a university in Italy, combined with Trend Micro, cybersecurity company, looked at, well, what industrial robots are causing problems out there? How are they being exposed? And actually, they found 83,000 industrial robots in this example, which had a number of vulnerabilities. And in this example, they identified the software running on the robots were outdated. It was based on vulnerable operating systems and libraries. Actually, some of the underlying cryptographic libraries were obsolete. They also had a weak authentication system with default unchangeable credentials, and I would say these are fixed, static, or similar, and possibly even used a static key across multiple robots, which is never a good idea. And they also found tens of thousands of industrial devices residing on public IP addresses, i.e. exposed to everyone out on the internet. So an attacker can access them and compromise them quite easily by seeing what type of robot it is and how to get on them. So if we think about how John's last slide fits within that, then you can sort of draw the two analogies here. So the first thing here is a safety risk, of course. Once an attacker would exploit the weakness of these robots, they could cause the operator to get injured, as an example. So that's a safety risk. Another one is an operational risk where the robots have an accident to take down the production line. That's a kind of a denial of service attack, a different one to the ones we see out there today, but it's still a denial of service. And then there's a compliance risk, which is maybe it's inaccurate products that are being manufactured. An example of this could be things like the pharmaceutical production line where they're producing substandard drugs. It's obviously not a good thing. So some potential solutions we could think about for this would be, perhaps you want to use a strong authentication scheme, checking the device integrity, including the firmware, in fact, and also checking the device identity to prove that the device is who it says it is, and checking the firmware hasn't changed in some way. Also, perhaps you want to use make sure you use credentials that are not fixed and static, that can change on a regular basis, perhaps through policy, and also keep these credentials in a very safe place. So if someone does manage to break on, they can't steal them and use them. Also, you could include the most up-to-date software with the most relevant software patches to your product before shipping it out the door. But coupled to this, you should also provide a mechanism for regular firmware updates so that you can push fixes to your products in the field if all else goes wrong. And when deploying the devices, looking at this example, you could do some basic checks here. So things like don't use public IP addresses, use private IP addresses, and perhaps even restrict the IP access to these devices, i.e. IP whitelisting, as an example. So those are just some potential solutions in this particular use case. The next one I wanted to talk about is really around the surveillance camera piece. And as we've all seen, probably a lot of you have seen all the sort of DDoS style attacks, and I don't think there's a day goes by, or a month certainly goes by, without some kind of DDoS attack using a camera. In this example here, they used sort of 1.5 million connected devices and cameras to take down a well-known security journalist website, Krebs Online, KrebsOnSecurity.com. And what they did really was the attackers used these devices and others on unsecure online devices to connect to the journalist website and basically bombard the website with requests in an attempt to make it collapse. Well, how did they do this? It was really that the bulk of the cameras used in the attack were from one manufacturer, and the attackers found basically a vulnerability to the way you could access the camera. And actually, the way they did this was to type in too many characters into the camera to gain access. And once they accessed the proprietary, introduced malware into the cameras and turned them into botnets to orchestrate a staggering encrypted DDoS attack. And actually, the DDoS attack surpassed 660 gigabits of traffic, which actually was quite a historic amount of data. But not related to just a specific attack, but a lot of DDoS-style attacks in the past using cameras certainly start by scanning all the open ports for cameras on the internet, which is usually freely available on the internet to download. And then you can find the model number of the camera, you can then search for default username and passwords and then input them. Then this allows attackers to gain access to the administrative password and take control of the device. So this is not a good idea, of course. So what can we do about this? What's the potential solution to mitigate these problems? Well, the first thing I think about is, well, provide a secure solution to upgrade the cameras to mitigate against the exploits. At least have a fallback scenario where you can upgrade the cameras and fix the back door. The second point here is really why IP whitelisted cameras. Don't let other IP addresses access the cameras unless it's intentional. Perhaps the next point is, well, check the firmware integrity of the camera. Make sure that if it changes, perhaps you get notified and you can lock out the camera on your network. It shouldn't have changed, so why do you want it on your network? Until you at least investigate what's going on with it. And in the case of a PerSRI, use a strong, unique password. Don't ship products with default username and passwords, ideally, and provide a solution which allows you to rotate the password remotely and securely in a centralized way. These are just a few ideas to combat some of these challenges with surveillance cameras. And the last one really I've got here is around smart home consumer lighting, which actually seems to be becoming more and more prevalent. Smart lighting lets you control bulbs in your smartphone, from your smartphone and tablet, and gives you more options to control your lighting at home. Perhaps you want to drive home from work, come down the drive and turn the lights on before you get in the house. But a lot of these devices don't encrypt the data between the application and the bulbs, and you can't set up a password for accessing them, which ultimately makes it too easy for hackers to infiltrate and control the devices. I mean, if your intention was to take out a power substation, then maybe one way would be to hack multiple smart bulbs in hundreds of homes and introduce malware to control them, turn them all on at the same time, or power surging them, for example. Or perhaps if you're a burglar, they could snoop the data and detect when people are consistently vacant from properties, then burgle the property, which is another sort of attack vector there from a burglar. So these are just some of the sort of examples we've seen recently around sort of potential vulnerabilities in IoT products. So John, just thinking about those, what's the implication of these from a systems integrator's perspective?
Thanks, Rob. So from a system integrator's perspective, we've really got to look at how we address all of those challenges. And the implication really comes back to this fact that we're now outside of the safe environment that we normally do as a system integrator. You've normally been in the past behind a wall. Some of the system integrators, even in industrial or oil and gas environments, we very much have been in the past protected behind the corporate firewall, as it were. So the other issue that really is around, as we move from that, is that we've got a series of different players that are involved in bringing a solution together, and bringing that solution together for the different use cases that each customer has, or how they actually want to go about that. So from the top, we've got someone who's the connectivity provider. This could be the network provider, sort of the Vodafones, Telefonica, O2, etc., through to MVNOs, for example, like Stream, IoT. And you have to work with a connectivity provider to be sure that any drop-offs into or out of the network that you're making sure is secure, because they will assure you about the security of that network overall, but it's those ramps in and off the network that you have to consider. You've got the hardware provider, so for a lot of customers, they've probably got a dumb product, one that's not previously been connected, and you're adding on additional feature or function. In a lot of cases, that's provided by a third-party hardware provider, and indeed they'll be providing the firmware on there, so you have to work with them to make sure that's secure. You've also got the hosting provider, Amazon, Azure, etc., where you have to understand and make sure that the connection between what the connectivity provider is providing and your hosting provider are joined up also, so there's no off-ramps at that point that people can exploit. A lot of the IoT applications that we build, all of our IoT applications that we build, for example, are built on ThingWorx. So we have to work with the platform provider, in this case PTC and their ThingWorx product, to make sure that what we're designing and developing and the security that we're putting in place is consistent with all the other elements of the design that we're doing. And then we're the system integrator sort of orchestrating on that. So we have to, as a system integrator, make sure that security is designed in. But really, where does that responsibility lie? If there's something that goes wrong, where does the responsibility lie? The customer can't abdicate responsibility. The customer, as in the person that's providing the device into the field, they can't abdicate that responsibility in law, either through GDPR or the medical device regulation or HIPAA or the equivalents under FDA, but they can in contract. So the question really is, who takes this hot potato? Who takes the hot potato of security? And what we've found is actually the best way of addressing this is adopting the posture as a group that if one of us fails, we all fail. This means you have to get used to asking each other really quite difficult questions in the relationship about how we're doing security and sharing, in some cases, what are quite commercial and sensitive data information about internal working practices of those groups and their security postures to make sure that we've got the security covered. So that's the first big challenge, is herding the cats of security, all the different people that are involved in making sure an end product is secure. The second thing is in the way you develop as well. So we've more and more gone from a waterfall method where we've gone from designing in from the start, following an execution, etc. Because we found that we have to be agile. You know, particularly in the IoT, we're looking for where the value is and where customers are making the most from that value. So a lot of us have adopted an agile approach. The thing with an agile approach is sometimes it feels that the plan is the first casualty of war, if you like. And what we're finding is that you then go down different routes where other items are getting prioritized first. That's the way of agile. But what you have to do is make sure that what you're not doing is deprioritizing some of the basic security stuff that you have to do to make sure your product is secure. And you also have to make sure that when you prioritize another agile item in your sprint to be part of your release, that you've considered that true from an end-to-end perspective. So at the beginning of each sprint and at the end of each sprint review, you have to make sure that you've designed and have implemented the security in line with the design as you're going through, as it's done. Finally, as well as a system integrator, you know, it used to be in the day when you got big sigh of relief, you've delivered the product, it's signed off by the customer, etc. That's it, right? Move on to your next job as a system integrator. That's also going away now. What you find is you've got to have, not only you've got to build the product, but you've also got to work alongside your customer on an ongoing basis and provide some form of managed service to help make sure and maintain that design security, that designed in security, because it's a bit of an arms race. You know, as people are coming up with new methods, new forms of attack, new attack surfaces are found and exploited, you have to respond to that and come back to that. So the other key area as well, and because of that, is that you have to consider this. Look, you can't use a manual process to manage those devices in the field. Security itself cannot be done in a manual way. So you've got to look for processes to register devices that aren't manual, because for 10,000 devices per month, for example, that's a significant overhead if that was done manually. You have to have automated ways of identifying and revoking potentially certificates if a device becomes compromised. You've got to look at how you maintain your certificates if you are using certificate authentication, and how you manage the renewal of those certificates so that you don't accidentally brick your device in the field. And you've got to manage this idea of authentication at scale, and as well as devices coming on at each session, and the scale becomes impossible in that way. So those are the types of things that you've really got to consider as a system integrator. You've got to deal with the fact that you've got multiple parties that are involved in the relationship, multiple people who individually are responsible for delivering their element of the security. But as a system integrator with the customer, you have to share accountability for delivering the security overall. So that said, how do we go about this then? How do we actually go about this, and what are the best practices? Where do we start? So Rob, you know, talk me through. You were involved in the IoT Security Foundation. What are the sort of things they're doing as an example, and what are you doing with them?
Yeah, so thanks, John. So you're right. I mean, it's always a good place to start. What are the best practices? What guidelines are out there? And in fact, the IoT Security Foundation was really established to respond to a myriad of challenges over security, specifically around IoT products. And really the mission is to help secure the Internet of Things to aid its adoption. You know, there's a huge potential growth in IoT, and also, you know, obviously huge revenue potential in IoT. But I think all that will be scuppered unless security is taken really, really seriously. So yeah, this group was really set up to, you know, to focus in on the IoT and how to secure it. And then there's 7 key working groups here, which some of these we are involved with. These are broken into WG1, which is all about self-certification scheme, which really sets out to determine a set of requirements for a low-cost, accessible, and relatively actionable system of self-certification. And WG2 is really around connected consumer products, which is really looking at the objective of this working group is to produce security best practice guidelines. And actually, these guidelines are very, very useful and good. I would really recommend you to go and look at the best practice guidelines online. They're like one pages, and there's about 8 or 9 of them to showcase, okay, for end-to-end crypto, these are the type of things you need to consider. And there's other aspects in there as well. So they're really, really useful. WG3 is actually under scope at the moment. WG4 is all about vulnerability disclosure guidance. So what, if something does happen with your end product and there is a vulnerability that you found or somebody's found, what do you do about it? There's no good just sitting on it. You need to do something about it. And this sets out to give you guidelines and processes that you should adopt to work that through and find a solution for it. And then WG5 is all about the IoT security landscape. So this is working group mapped applications of IoT at high level. So really looking at the end-to-end perspective to identify vulnerabilities across the whole sort of landscape there. WG6 is really about smart building. So this is a working group that's really been set up to establish a set of guidelines and looking at the supply chain participants, specify, procure, and install and integrate around sort of smart buildings, really, and how you operate IoT in smart buildings. And the last one really here is WG7, and that's really around Trustmark. And this group is really set up to kind of like give a sort of certification mark, if you like, for companies. So if you follow certain guidelines, then you can be sort of given a trust mark, so to speak, which gives end consumers or end customers a good idea that you've actually followed some guidelines to meet a certain level of standard. But you can find a lot more out by visiting the IoTSF website, which I would encourage you all to do. So that's really about some of the best practice sort of guidelines and things. But I think it'd be really good just to talk about some examples and figure out how does it really apply. So I think John's really going to now start to talk about end-to-end data encryption.
Right, thanks, Rob. So we've heard about the best practices, and there are a plethora of things that you should do. One of those main areas that we've got in the best practice guide is end-to-end data encryption. We thought we'd use the example here of Asset Minder, which is InVMA's product, which is used to connect remote devices, normally things that, as I describe them, that are big, hot, or vibrate, things like compressors, centrifuges, etc. And we connect those up, and the advantage of Asset Minder is that you can connect many different machines and devices and produce one view of the data and connect to other systems using that. But obviously that comes with a level. Some of the machines that we connect to, there's a two-way communication, so we can remotely start and stop machines, which has a whole issue around safety and safety compliance. We have to look at FMEAs on all of that and do our safety analysis. And so we've got to be very sure that the messages that we're sending from the platform to the machine and the messages we're getting from the machine back to the platform are real and from who we think they are. So that's why we've implemented Device Authority Keyscaler to manage this end-to-end data encryption as one of the elements of Keyscaler. So the way it works is we've got a little bit of ThingWorx that's running on the edge on a gateway that's connected up to the asset. That edge device is monitoring constantly the parameters that the engine is, in this case for a generator, constantly monitoring the generator engine and just looking at things like temperature, vibration, whether there are any active alarms, etc. and only sending back data when it would be of importance to the edge. So the thing is that what we want to do though is we want to store that data locally, and what we also want to do is only send the data when it needs to be sent. But how do we know that that device that's communicating with us, that asset, is the device that we know? And we use an always-on agent, a crypto agent, a small piece of software that sits on the edge next to the ThingWorx edge device. And basically what's that doing is as soon as the data is created, it's encrypting it. Before we do that though, what we have to do is we have to register on the network to say that we're there. So we've got a device registration authentication. So the device uses uniqueness of the device, or the entropy as we call it, to identify who it is. It's things like its MAC address, its chipset, what assets it's connected to, what firmware version it's running. We can use any element of that device, and that itself identifies the uniqueness, and that is then challenged, and the response from the device authority keyscaler to say you are who you say you are. And it doesn't really stop there. Once it has been authenticated, the crypto agent locally creates, using the uniqueness of the device, this entropy that I've talked about, its own key, and it does it dynamically at each of the sessions that this happens. So this key is created, and that then is used to encrypt the information that is then sent across to, in this case, the ThingWorx server. The ThingWorx server itself also authenticates itself against keyscaler to say, hey, I am who I say I am, and it then stores the data encrypted, and we can choose whether to decrypt at the point it hits the server, or we can actually store it at rest and encrypt it, which is what we do. And then at runtime, what happens when someone interrogates, ThingWorx itself goes and confirms to keyscaler that it is who it says it is, and then keyscaler then issues the key for that session for it to decrypt what it is that it's seeing. So what we've got is really from the edge, the key features here is from the edge through the network through to the server, we can choose not to have any decryption until at runtime. The second thing is we rotate the keys at each session, so it doesn't matter when this happens, you're not having keys stored anywhere at any time. And just so secure from the factory, we can ship it out already with its own security posture and policy in there, and then we can choose to change that depending on the asset and the circumstance in which we're using that asset. So really, hopefully, that sort of covered really that one best practice example of end-to-end data encryption. So Rob, have you got any other examples?
Yeah, sure. So let's just move on to this next example really here, which is looking at machine model data and IP protection. And if you think about sort of Smart Factory 4.0, then this is moving towards sort of data analytics and management outside the factory itself. If you can imagine that the factories are, adding more and more sensors, more and more compute, the sort of factory installation people when they design the factories have to think about, well, do I install a data center in my factory locally, or do I push my data to the cloud and do I manage it remotely? Well, the second part of that obviously has a lot more security challenges around it. And specifically in this example, well, how do I protect my model data and IP protection of my models going into my machines? And in this example here, what we've got is a milling machine on the edge, and that milling machine is small in the image, but actually it's about the size of my house and weighs about 100 tons. So it's quite a big thing. But key things here as well, for example, how do I protect the model data going to the machine and stop it being stolen and used against me? Perhaps it's industrial espionage, an example. How do I prevent somebody causing havoc with the machine? How can I secure the usage information and audit trail for the components that are produced on the machine? And how do I provide irrefutable evidence from the source? Well, in this example, what we're actually doing is similar to what John promoted earlier, is that we have an agent that runs on the or close to the machine itself, which is proving its identity and integrity, which means the milling machine would check into the keyscaler system and prove its authenticity and check the firmware integrity, etc. So the actual steps that are involved here is that we've got Acme manufacturing on the right-hand side, which are producing machine models, sensitive models. Perhaps they want to get machines in their factory, which is say thousands of miles away or hundreds of miles away. Through step one here, what the Acme manufacturing are doing is getting their model data encrypted. They're then pushing that through step two into a platform or some type to store the files, and then at some point in time, step three, there could be an instruction through your management platform to say, okay, I want this machine to machine the model. At which point you might want to say, okay, before I do that, let's really check to see the machine is who it says it is and make sure it's authentic. At which point the machine would be told through the agent to go and authenticate itself to Keyscaler. And then there's this challenge response mechanism, as John mentioned earlier, whereby the machine is proving its identity and integrity and proving that it is authenticated to process this model data. At which point, assuming that it's a credible device, then through step 5 we can deliver the encrypted file and decrypt the file, and then the machine can machine the data. And also, as a side sort of challenge here, what we're doing is providing a usage and audit trail or encrypting all that data back to the IoT platform so that you can, give an irrefutable evidence trail from the source. Say, yes, this machine has machined this model, and this is when it did it, and this is how it proves its identity. So that's, sort of one area which is interesting for machines as well. But moving on to the next example, and we talked about cameras a little bit earlier, and cameras, are used in all kinds of applications. In fact, when we were talking about manufacturing lines as an example here, but they could be used in all kinds of applications and including manufacturing lines. In fact, we see lots of applications where they're used to monitor production lines to see whether there's any objects in the way, something that's causing the production line to be stopped in some way. These are all really important things, and these cameras are being used in all those type of applications these days. But a couple of things to observe in these cameras is that 98 million network cameras which were shipped globally in 2017, and less than 1% of these will have certificates on them today, which is, certificates are generally used to authenticate the camera to a VMS, a video management system, for example. Without a certificate, you can't do that typically today. And why these are the case is because I think it's too hard to manage, and they all need secure credentials, and also the IoT gateway market has similar challenges. So in this example here, again, very similar to the last couple, we have an agent on board the camera, which through step 1 would register, authenticate, and prove its identity to Keyscaler, so we can check things like firmware integrity, the identity of the edge device, and check to say, yes, this is a credible device. Then through steps 2 and 3, what we're doing is getting a CSR or certificate sign request generated and signing that through either a public CA or private CA, whatever the preference is for the customer, and then delivering that back through step 4 to the camera and potentially to the VMS system. So we're automating that whole process so that the camera can authenticate itself to the Keyscaler, so we can deliver the certificate and also then get a mutual authentication between the camera and the VMS. So securing the communications between the camera and the VMS. And on a side note there, what we're also obviously supporting in a similar solution is the ability to manage passwords on the cameras and other remote devices, meaning that default passwords are no longer a problem, because using the agent on board the camera, you can rotate them remotely and provide access to them via technicians as and when needed to through policy or by updating the password on demand. So that's really a little bit about a couple of use case examples there. So what I really wanted to move on to now is why why have we seen some of the previous example attacks, and what are the operational implications you need to consider. And for me, one of the main reasons why businesses haven't taken security seriously for IoT up until date has been it's really challenging at IoT scale to manage at an operational level when you're considering the scale of IoT devices, things with hundreds of thousands or tens of thousands of devices. For sure, if you've got 10 devices, you can probably manage that through a manual sort of process, but when you got into large volume, you're going to struggle. And these are the sort of things I think you need to consider. So you need to really consider how you automate the device registration, onboarding and provisioning. How do you do this without having a huge team of people to onboard your devices? Also, how you need some way to automate the device authentication at IoT at scale. How do you do that without some automated provisioning and automated authentication scheme? And you should also look at things like how to automate the provision, renewal, and revocation of credentials for devices. I mean, if you want to work within standard, well-proven frameworks such as PKIs, then how do you get the certificates and credentials onto these end devices and manage them as an ongoing basis? So whether I want to renew the certificates through policy, or perhaps I want to revoke them. If you want to do that at IoT scale, you need a mechanism in place to do that. Password management is also an important piece of the puzzle here. In our view, you should have a remote access and remote way to manage these passwords. Don't leave the door open by using default username and passwords. It's never a good thing. And one of the final sort of things here is really you should have an automated way to update the firmware in a secure way. You need to future-proof your product. Make sure you can update it securely. So if all things fail, at least be able to update the firmware and do something about it. So that's kind of a little bit about sort of the operational implications. So John, as a sort of a system integrator, what advice would you give really to anyone that's listening?
So really, how do we go about this? What are the simple steps? And I put simple in inverted commas because they're simple to write down, but some of them are quite tricky to execute. The first one is really appoint a accountable person. So this is talking about you as a customer potentially, or you as a system integrator, or you as a software provider, or service provider, or indeed a connectivity provider. Is you've got to appoint an accountable person, someone in the organisation who's truly accountable for understanding and delivering the security that's required. That doesn't mean that person does everything, but it does mean that that person is responsible or accountable for making sure that the true end-to-end of the security of the device and the projects that you're doing is being done. You need that person and the group of people associated with that really, and as a senior leadership team, you need to understand the legislation that's around your product and your asset and the world in which you're working. And that's directly, as we spoke about previously, but also the other areas of legislation that are going to impact you, the GDPR, for example, that we spoke about. So once you've got the person, once they understand legislation and understand more about the why and the what you've got to do, you need to adopt a methodology, and that's really we sort of suggested these 5 steps, but Rob's just taking you through some of the other methods that are there, but simply there are 5 key steps you've got to think about. You've got to review your end-to-end posture. How are you going to defend yourself? Why will people be attack you? What's the risk, and where's the area of focus that you need to put your attention to secure your product? I mentioned it earlier, but the real key thing here is designing security from the start, but also review at the beginning and the end of each sprint what that has meant to your security posture and the difficulties that you found during the sprint, how that may or may not have impacted your security posture. Update and go and have a look at what we use as sort of classic FMEA approach of what are the failure modes and the consequence of those failure modes to you and your customers. Once you've done that, you also, when you're coming to do your design, you've got to choose the solutions designed for the Internet of Things and really think about this scale question that Rob's been alluding to. How are we going to manage this at scale? How are we going to manage key rotation? How are we going to manage firmware updates? How are we going to manage making sure that our device is still secure as we do that? And the way to do that is choose solutions that are designed for IoT. So we as a reseller have chosen ThingWorx and Device Authorities, 2 of our key solutions that we use to design and implement our applications. And then you've got to test. You've got to test your solution and test again. And this is from penetration testing, right the way through to just people getting access to areas on your application. So classic testing through to full end-to-end testing. And then finally, as we mentioned before, you've got to have a process in to monitor and review when your device is out in the field. Long gone are the days of job done, it's over the wall and away you go. They're long gone. And you've really got to understand and monitor and keep an eye on your products in the field, whether that's monitoring the network traffic, whether that's using artificial intelligence even to monitor network traffic, right away through to just even checking how much file space your firmware is taking up on your device. Simple things like that to see if you have been attacked, because you'll get attacked because someone's thought of something that you haven't. So you've got to look out to identify early when someone has made that attack, and you need to be the first person to know. You don't want your customers phoning you to tell you that you've been attacked. And finally, that all comes back to this one thing: as the leadership of your company or involved with the leadership of your companies, is it's your responsibility to build a culture. You've got to build a culture in the same way in the 70s in the UK there wasn't a culture around safety. There is a culture around safety and health and safety in the UK now. And that culture has come over a period of time. It's got to be the same with security. Have to recognise that it's out there. etc. You know, at the end of the day, bluntly, our simple steps are predicated by one thing: hope is not a strategy when it comes to managing your security. So those are the sort of simple steps we do. Rob, you got any comments about the steps?
No, I think they're really good, to be honest, John. I think you've captured everything there. And I like to use this, the last one you talked about was monitor and review in the field. And, you know, if you think about sort of antibiotics, I used to sort of think that in my head. You know, antibiotics started off as, you know, fixing a particular problem for a virus, right? But over years, been various antibiotics being developed because there's new viruses come out, new strains that come out. And it's the same with security. You know, you can't just ship out your product and forget about it. You have to constantly review it, adjust it, make fixes and patch it, because people will make software which is going to make them vulnerable.
Okay, so just to summarise what we said we were going to do today and on this webinar before I opened it up to Q&A, we said that we were going to give you some areas to help you understand some of the attack surfaces, and Rob took you through device level, network and server. Obviously there's much more to talk about in that area, but in the time we had available, that's what we covered. We gave you some examples of how devices had been you know, shown their insecurities, and we've shown how you could protect against those and discussed how that could happen. We focused there in the areas of authentication, on the areas of end-to-end cryptography, and also this idea of automating your security as being one of the real reasons why they're insecure. And we hope that we've made you aware of some of the best practices and some of the areas that you can go to get more information, for example, from the IT Security Foundation. So I'm just looking now just to see. We've opened up to questions. You should see that you've got the questions there. If anyone's got any questions, please write now, and we'll do our best to answer them for you. Okay, so this is an interesting one that's come in. Okay, what do you see as the biggest challenge in IoT security today? I think, Rob, that's one for you.
Oh, thank you, John. Well, to be honest, I think IoT adoption has been hindered by the perceived complexity and challenges around, you know, sort of automation as an example. I mean, I don't think any one sort of customer can really do everything in IoT. I think really you need to partner with the right people with the expertise to manage that. And to build in the right expertise and pull it in when you need to for a specific project. And that's where I see really IoT is going to be successful, is to pull in the right expertise when you need to. So I think, you know, the challenges are there. You know, security needs to be at the forefront, but there are sort of vendors out there which can help build those products and make them secure.
Great, thanks, Rob. That's really useful and interesting. Thank you. So yeah, there's another one that's come in here actually, which is okay, how do you contractually cover the risk? Well, I guess I'll take that one. We found that there's two ways of sort of contractually using risk. The first one is where the system integrator themselves takes the risk on. It's the single throat to choke. So that sort of slide where I showed you've got all the different parties, etc. The system integrator sort of takes that on and then tries to lay that risk off against the other contracts on a sort of on back-to-back kind of approach. The advantage for the customer around that is they do have the one person to sue, but limited to that also they only have the one balance sheet to go after if things go wrong. It does align the system integrator directly with the customer, making sure that they are quite literally standing in the customer's shoes to make sure that the end-to-end security is adopted. The downside of that is that it leads to the customer having a false sense of security, that it's the system integrator's priority, and they themselves may be acting in a way that that limits the security and indeed then limits the system integrator's liability. The second approach is the more dispersed approach, where the customer themselves contracts individually with the companies, but then makes them equally culpable in the response if there's an attack of some form that should have been identified, so that basically everybody's looking out for the end-to-end solution there. And the advantage of that is that you've got everybody's balance sheet involved, and it's almost like a joint and several liability. This all comes down to the commercials. One of them is a cheaper way than the other, You know, joint and several liability, probably or joint liability, certainly not several, is would be more cheap than the other. But there's several ways. But yeah, very good and challenging question. Thank you for that one. Yeah. What have you got? What's the other one we got through there, Rob? Can you see that?
That's all of them actually.
Yeah. Okay.
So
okay. Great. Well, we're finished a little early. We've got 5 more minutes. If anyone's got any more questions, then please do. Please just drop us a line quickly. That'd be great.
Or if you're attending the IoT Solutions World Congress next week, please do feel free to come along and have a chat with us. We're on booth B240, and yeah, look forward to seeing you if you're there.
The other thing I'd like to mention as well is that, you know, on our website, on the InVMA website, we can sign up for a free workshop to go through and talk about the Internet of Things and how that can help you and explore that with you, and also discuss some of the security issues, etc., that we've been talking about today. Keyscaler itself is also available on the Amazon Web Services Marketplace. But if you want more information, please don't hesitate to contact me, John Hill, at InVMA, or Rob Dobson at Device Authority, and those are the details of our websites. But thank you very much, and hopefully we will also be issuing this as a video so that you can watch again at your leisure and forward to your colleagues as you seem appropriate. Thank you.